Hello everyone. I'm honored to be here at the International Conference Digital Technology Driven Engineering. Recommender systems play a critical role in a modern digital platform such as e-commerce, streaming services, and smart applications. However, most existing recommender systems rely on centralized architecture, which raises serious concerns regarding privacy, transparency, and user trust. In this work, I've proposed a PPS and PRS, a privacy-preserving and scalable blockchain based on a recommender system framework that integrates Ethereum, smart contracts, IPFS, and a hybrid deep learning model. In this presentation, I'll briefly discuss the motivation system architecture, workflow, experimental results, and ethical impl implications of our approach. Traditional recommender systems collect the processes large volumes of sensitive user data on centralized servers and making them vulnerable to the data breaches, misuse, and unauthorized access. Federated learning improves privacy by keeping data on a user's devices, but it still relies on a central aggregator, which introduces the trust and scalability bottlenecks. Blockchain technology offers decentralized and immutability and transparency, making it attractive solutions for a privacy-aware system. The key contributions of this work is the PPS and PRS as unified framework that combines blockchains off-chain storage and deep learning to achieve privacy, preservation, scalability, and high recommendations accuracy. Figure shows the three layers architecture of proposed PPS and PRS framework. The first layer is a blockchain layer implemented using Ethereum smart contract. This layer is responsible for managing user identities and access control, data integrity, and insensitive metrics. The second layer is off-chain storage layer implemented using IPFS. Large and sensitive user data are encrypted and sorted off-chain to reduce blockchain's overhead and improve their scalability. The third layer is the intelligent recommendations layer, which combines the dual-light GCN and the Muffin IN to generate accurate and content-aware recommendations. Overall, this layer design clearly separates the trust management, data storage, and learning tasks, ensuring both efficiency and security. This slide shows the end-to-end workflow of PPS and PRS from the left to the right. The first user interacts with the system and generates preferences data. Before leaving the client's device, the data are encrypted to ensure privacy. The encrypted data is sorted in IPFS, which generates a unique content identifier, or the CID only. The hash access, the metadata are sorted on the blockchain via smart contract model training, and interfaces are performed off-chain using verified data. Finally, recommendations are deliverable to users and verified. Their feedback is fed back into the system's continuous improvement. The recommendations engine is based on a hybrid deep learning model. The dual-light GCN is used to model user item interaction as a graph, capturing higher-order relationships that traditional metrics-based methods often miss. This allows the system to deliver richer structural and textual representations. On top of this, the Methane performs multiple information fusion by integrating multi-modules features, including user behavior, item attributes, and contextual signals. That combination significantly improves recommendations accuracy and adaptability in a dynamic environment. Let's present the basic code of the smart contract logic used in PPS and PRS. Each user first register and receive a blockchain wallet. User data are encrypted and uploaded to IPPX, and then CID is generated. Only the hash of this CID is sorted on a blockchain, ensuring integrity without exposing the raw data. When an access request is made, the smart contract verifies permissions and digital signatures. When access request is made, a smart contract verifies permissions and digital signatures upon successful verification. Access is granted and incentive or rewards are distributed. The design ensures secure, auditable, and privacy-preserving data is transactions. We evaluated the PPS and PRS using the movie lens 1M dataset, which is widely used benchmark for recommended systems. Blockchain experiments were conducted on the Ethereum Glory testnet to simulate real-world smart contract executions. The IPVS were used to decentralize off-chain storage encrypted data. The recommendations module were implemented and trained using PyTorch, while smart contracts were written in Solidity. This setups ensure reproducibility and realistic performance evaluation. Chart compares the PPS and PRS with conventional federated recommender systems. The PRS achieves a 12% improvement precision at 10 and 16% improvement in recall. 10. The scalability index improved by 35%, mainly due to IPFS based on the chain storage and reduces blockchain load. Latencies is reduced by 26, demonstrating that privacy and decentralized do not necessarily cover the cost of performance. These results is directly corresponded in chart table 3 and figure 2 in the paper. This slide addresses the explainability and ethical considerations which are important for reviewers and real-world adoptions. Blockchains provides transparent and tamper-proof logs of all data interaction, enabling auditability. Users retain ownership and control over their data through cryptographic keys. The graph-based onboarding module improves the explainability by making user-item relationship more interpretable. Overall, the PPS and PRS aligns with ethical AI principle and data protections regulations such as the GDPR. To conclude, the PPS and PRS privacy-preserving and scalable blockchain enable recommender systems by combining Ethereum smart contract, IPFS, and a hybrid deep learning module framework outperforms federated approaches in accuracy and scalability and latency. The system supports transparency, trust, ethical AI, making suitable for real-world deployment in domains such as e-commerce, education, and smart cities. Thank you so much for having me in this conference, and I do welcome any questions. Thank you.